Thank you for attending my talk today, where we're really talking about regional soil geochemistry for exploration. And I've got three key areas that I'll focus on. That's the strategy, which is sort of the things you would want to consider in setting up a regional soil geochemistry survey, some of the solutions, a little bit around the tricks and tips. And then I'm also going to put in what I've titled the soapbox. So it's a bit of the way I think about some of the geochemistry dogma over the past 30 years that possibly haven't questioned a few things that we could have done differently, and possibly give you some options on how we can advance our soil geochemistry surveys going forward. And one of the first questions people think about with regional surveys is what scale and what works. And really, as you'll see in the next couple of slides, it's not necessarily about the scale as in the distance between points. What's more important about observing interesting patterns in the data is the number of samples. And it comes down to about 1,000 samples, which was the outcome of a paper by Dave Smith and Clemens Ryman in 2008, noted there. And when you had that number of samples, or greater than quite a few hundred really, you start to observe patterns that are representative of the region. And so you can see here in these two examples where we've got on the left-hand side, Evgeny Bastrikov from Geoscience Australia presenting some of the work from a very large region, over quite a few hundred kilometres, copper and soil survey. And you can observe the trends there with the different colours in the background. And so quite broad spacing, not necessarily a gridded sampling. And then on the right, you see Alekos Dimitriades, you could say regional soil survey, but it's on a much tighter scale, similar number of samples. And again, you see those observed patterns because you have that density data that you can work with, even though that's only, a few kilometres across. The other question that would come up early on in a soil survey is actually, what is the media? Is it all soil? And this is a question that I think we don't often ask ourselves enough, because a soil is made up of many different components. It has a lot of different variation within it, as you'll see in some of the following slides, where depending on how you sample or what you consider to be a true soil or a sample media may influence your results quite significantly. And here's the first soapbox, I guess, to demonstrate that with this beautiful soil profile from the Kursk Oblast in Russia, where if you were sampling near the surface, you can see very organic, rich soils there, you would get very, very different chemistry from someone that might be sampling from about 1.5 meters down in the sort of windblown, leached silt material that's there in the lighter color. And again, you can see an even different transition into the very orange sands at the base. So one of my key messages here is that soils are not all the same, and they vary quite significantly. And we really need to take that into account, probably better than we traditionally do when we look at regional geochemistry surveys, because people have tended to focus very much on the chemistry and not necessarily considered some of the other parameters around it. And I'll show a few more examples of that going forward. Other components in soils are things such as the binding material or the cementing agents. So in Australia in particular, and some of the other arid, semi-arid regions of the world, calcrete has been a very popular sampling medium. So this is pedogenic carbonate. It's often associated with exploration for gold. And you can see in regions of the world, it's quite well spread and easily sampled, but you can see in the far right image there where the white is that pedogenic carbonate. It's not consistent. It's not all white. It's not all carbonate. There's actually a mix of clays in there. And so again, even though you might be sampling that carbonate horizon, the percentages of carbonate you get in there are quite varied. So understanding that potential sampling media and maybe some of the variance in it is important to guide how you might use this going forward. And these are the sorts of questions you need to ask early on in your planning and the strategy in devising the soil survey. Are your materials universal across your area? Are you going to be able to collect something that's representative? And again, it doesn't always necessarily have to be soil per se. It could be the calcretes, the silcretes, ferrocretes. It could be things like lags and gravels in certain cases, and I'll got some examples coming up, where those might be the ideal sample media for a regional soil geochemical survey. In Western Australia in particular, things like the lateritic duricrust is a very widely and successfully used sample media. But in the middle diagram there, you can see, just depending on the landscape position, that can vary quite a lot. So, you might be getting a very mixed gravels or lags, or something that's much more uniform. And again, we need to be considering these things as we're designing these surveys. I've already touched on the variance in soils, and you can just see here again a little bit of the variation in soil profiles, and depending on depth or depending on the weathering or whether it's eroded significantly, you might be picking up different horizons within those soils. So the figure there to the top left shows some of that horizon designation, and some of them you can see very clearly. Interestingly, those on the bottom left two samples, two soil profiles, those are actually not very far apart, and you can see they look distinctly different. So if you were planning a regional soil survey in this area, you may want to consider what sample media or what depth is the best part to be sampling. And then there are other, what I've titled other odds and sods in that regional soil geochemistry survey media. It's not, even though the termite mound represented there on the left is predominantly soil, and it is representative of a larger area around it where it gets piled up, is that a viable sample media? And in some cases people have used it very successfully, but knowing what you're sampling and the variation within it is important before you go out. Likewise, there's large parts, not in Western Australia, but in the northern parts of Europe and Canada and places like that, where the wetlands are dominant. And so things with really high organic matter component are really important as well, or potentially widespread, and make a viable sample media. But again, it's about understanding what limitations or other things that we need to consider. So again, there's a large organic matter component in those samples now that isn't in some of the other soil surveys. So how do you compare those? How do you perhaps account for those in understanding the geochemistry? And we'll get to that a little bit later on, some of the methods you can do. Adjusting your elemental results for the organic carbon content is one obvious one. And likewise, people have done traditionally with the calcrete. They've looked at calcium content and scaled their data accordingly. There are other things within soils that we can sample as well. So I'll touch on different size fractions, but in some cases, people are after specific mineral grains within those soil samples. So indicator minerals, not heavily used in Australia, but certainly a dominant regional soil survey sort of approach that can be used in places like Canada. And so these are all the different considerations people might need in terms of forming a strategy about how to go about generating a regional soil survey. And then there's the information you might want to collect while you're in the field. So that's the other part of the strategy, is understanding what information you need to get while you're in the field. There's a recent report being generated, or an update of an older report from the Association of Applied Geochemists. And in that, it's all about reporting geochemical data. And there's a whole lot of appendices at the back that are being refreshed around different sample media and what you might need to consider. I've authored the one on soil sampling. So that's why I know it's there, and it should be available freely. So that's coming out, and you can look for that online at the association's website. So that gives an overview of the sort of information you might want to consider, and I'll touch on that as we go through now. One of the other things is how you collect that information, whether you use traditional paper and notes versus the more, I guess, digital advanced techniques that people are using now with tablets and devices where you can rapidly capture a lot more information. Although people sometimes think that they can crash and lose information, but I think that's probably where we're going in the future. And certainly I've been a convert to that way of gathering data over the last few years. Other sort of equipment and supplies that you need to consider early on is, obviously you need to know the location and where you're going. Satellite imagery and the maps that are available now before you get to the field, and I'll come back to why that's important a little bit later as well. But having that information before you plan your regional soil survey is really critical to getting the best results. And it will inform even how you locate your points potentially. Types of equipment to use and collect, and whether there's cleaning steps and a protocol with guiding those sample selection and recovery. There's a lot of different ways, and I'm not going to go through those. You can use augers, people use power augers, people use shovels, backhoes, little scoops in some cases. There's a range of different equipment and techniques to go about collecting a soil sample. And then there's some field preparation steps. So to sieve or not to sieve, that is the question for these soils. And when you're doing a regional survey, do you spend that time in the field doing additional prep steps? And do you need to? And that's one of the considerations that we'll come back to quite often. And it really depends on what your approach and what your strategy is with your soil survey. There's some other field measurements that people don't often take, but probably should a little bit more. Things like soil pH, moisture contents. These are potentially important parameters that we don't often measure. And then there's sample bags. You don't want to be mixing up materials as you go through. So you want to note those and the size and things like that, and the way you want to identify them. This is, I think, really important. Typical labels and stuff of the past are great, but being able to digitally track and find the provenance of samples in the future is going to become even more valuable. And so having really good QR codes and things like that, being able to track those all the way through the laboratory process is really valuable. And so I think that's a sort of technique that people are moving towards. But again, it's just this understanding beforehand. And really the solution is just to be consistent with all the gear and the recording. It is that simple. It's about thinking about it before you get to the field, planning effectively, and really being consistent with all that you do. Some of the field notes, probably the most important one, I think, is around landscape position and parent material. Some of this, again, looking back at maps and other information, you'll be able to draw that information out later, but it's always great to get that in your first pass and while you're in the field. The depth, whether you're sampling near surface at a certain depth or morphology within soil profiles, interfaces and nonconformities are something that a number of us are using quite consistently, and some of that is in some of the deeper regolith and sedimentary environments. But these become important sampling zones, and so as long as you identify those early on and are consistent with it, you'll get really good results on a regional soil survey. And the big question is understanding whether you're looking really at transported or residual terrains, and that will inform a whole lot of not only the sampling, but also the techniques that you employ and perhaps your strategy in what you're trying to find. I'll come back a little bit more to that as well, about where the benefits are, in transported versus residual settings. Ideally, the parent material should be similar. You may cross a lot of different geology, but you want to be collecting, you don't want to be mixing, calcrete samples with soils with organic rich, bog peat material. That's just going to throw all your data and information out. In some cases, some of the parent material is truncated by weathering or stripping. In some cases, you're going to come across different settings. So it's really evident in the data you capture in the field, and also a number of other parameters that you can use. So being consistent with your information gathering is important to understanding those. And I think one of the things we're doing better as we move forward is how we evaluate those soils in different settings. And just here's a couple of pixelated images on the left to sort of show, how different some of the landscape may appear from the top. So these are settings in Western Australia on the left, it's very flat. There's not a lot of observed differences on the surface, but you can see on the picture in the middle there, there's a deep weathering profile in a lot of these things. There's often paleochannels, all sorts of changes are happening below the surface. And if you think about on the picture on the right, where you can see some of these different zones, you've got a complete weathering profile on the top. So if you're collecting on the top of the hill, you're getting, a residual soil. Whereas, on the side slope there, you're getting something that's been weathered away slightly, but still essentially localized. Whereas in that deeper regolith zone and the depositional setting, you might be getting material from that whole region. And trying to evaluate those chemistry signatures and understand, your best exploration targets within that can be challenging if you're just treating them all as the same sort of material. And one of the first things, one of the best solutions to getting around this is forming regolith maps. This is what most people will do, and there's different schemes. You don't necessarily have to be. This is one that people use with looking at residual, erosional, and depositional environments. Other people might bring in some of the ferruginous environments as well into that scheme. You can use soil maps if you've got the luxury of really good quality soil maps and geology in that region that you can sort of tie in to understand the landscape. But you can see in cross section here, and this is representative of some of those arid Western Australian environments in particular. You can have a very broad flat landscape, and this, that aeolian dust and colluvium alluvium there in paleochannel, that might be hundreds of meters across in many cases, sometimes even greater. And walking across the surface, you wouldn't recognize it. So it's important to try and gather that information as you go and understand that that's an environment you may encounter. And that's an arid or semi-arid setting, but it's not dissimilar to some of the different glacial settings and depths of cover that you may encounter in other parts of the world. And really the solution is to gather good data beforehand and look at orientation early on. So consider, both in vertical and horizontal positioning, do you want to, what does it look like when you go on a vertical? People often do the horizontal traverses across known mineralization, as you see a picture on the right there, where you'll see, there's an anomaly over the mineralized zone. So, ideally that might be a good sampling technique. But at this site where I've done quite a bit of work in the past, what we actually found was that the near surface wasn't the best in the environment, or not with some of the traditional techniques. But if you look down at that interface where the sands started to build up, to change over to clay-rich environment at that sort of interface that's highlighted on the left in the dashed blue circle, that was a zone where you would have picked out the anomalous or the enriched nickel, in this case over the nickel deposit below. But we wouldn't have known that information without doing some detailed orientation work beforehand and to understand those soil properties that we're likely to encounter. So that's the sort of thing I think is really important early on. And you don't always need to do the actual survey. You might be able to gather information from other reports in nearby areas. I've talked about field notes with depth of sample. Does that really matter? I think hopefully what you've seen in some of the previous slides is that the soils vary quite a lot. So sometimes if you're consistently sampling at 20 centimeters, you might be getting a very different soil sample in one zone to, quite a few, kilometers down the road, just by the profile being stripped or something like that. So one of the things we're working towards now is how do you account for those better and understand the properties of the soil so that you can evaluate what depth you might have taken that sample or get around that sort of variation. And it comes down to understanding soil types and classification as well. Now that can give you a little bit of a head start heading into an area to understand the soil classification. And there's a range of different soil classification schemes globally. The US one pictured on the left is quite prominent in a number of areas and well known. But then there's also some of the world reference bases for soil classification pictured on the right. And you can see there's a number of different classes. And it doesn't really matter as long as you can try and gather this information and get an understanding of the soils that you may encounter in your area. And when I was putting this talk together, one of the things I came across from IO Global was where they'd combined this sort of global soil map and broken it down into some of the key soil types that we might want to consider for regional soil surveys. And that really drives the type of sample media you might encounter. So for example, you can see in Western Australia there's a lot of desert soils classified, dry, semi-arid sort of regions. This is where things like those lateritic gravels occur. You can expect some of the cemented material and layers to be viable sample media. Whereas, you can see in Arctic soils, this is where you might be more in, or podzolic soils, this is where you might be getting into those, till type environments and things like that, where, you wouldn't be looking for those same materials because they just aren't there. So understanding these types of zones that you're getting into with your regional soil survey is also important information. And I think that was a really nice breakdown that they did in that presentation. Other things to incorporate in your field notes is really around the soil morphology. So if things change or you note slicken sides, for example, in the expanding clays pictured there on the left, or little blade features pictured on the right there, you can see those different colors, changes in the amounts of gravels and roots. These are really important observations that you should try to capture as well, particularly the rhodoxomorphic features, because that can really tell you a lot about the drainage. It will change your chemistry significantly. And sometimes it can be really subtle. I've been in some of these environments pictured on the right there, where a really subtle change in elevation, maybe only 30 centimeters in some cases, can drastically change the drainage and the features of those soils. Other field notes to make are around contamination. And sometimes it's not always obvious. One of the sampling gear, again, being consistent and noting what you're sampling gear, but if some people are using brand new shovels with paint on them, things that tend to have things like, in some cases, chromium, cobalt makeup in those paints, that can influence your chemistry. I would say generally use the same material all the way through. And often what we do is excavate with the metal implements and then maybe get in with the plastic implements to sort of get around that. Things like wedding rings and jewelry can contribute to false gold readings in some samples. I think people are more aware of those things nowadays. And the sensitivity of the instrumentation is so great that does get picked up. Things like sunscreen and zinc was also a problem in the past. It's not so much with some of the modern sunscreens. Understanding flooding in your terrain, if there is potential for water movement and lateral flow, that can be really influential, particularly if you're in I'd say a brownfields environment where you do, or an early or mid greenfields environment where you've got some drilling potentially nearby where those materials might be moving around. That's the sort of contamination you should be noting, and that does happen quite often. Plough layers and fertilizer application in agriculture are another one like this. So here's a nice example for nickel mineralization on a soil survey where we're looking for a northeast trending nickel zone, and you can see that in this image of just the geochemical results and the mineralization where we thought it was going to be trending through. So, it's sort of matched up, but then you see this thing splaying off to the left, and, some people might get excited about that if you didn't have it in context. But when you look at contamination, this turned out to be exactly where the road was, and that an adjacent mine site was hauling some of their ore down. And the signature in the soil geochemistry was exactly anomalous for the elements that were part of that ore material that was being transported. So you do pick up these signatures in soils adjacent to these settings. So understanding that potential for contamination is important. The solution is around really good quality data capture, and that can be by paper and old school photography and things like that. We use a field information management system. There's a paper, I think I'll reference it in the upcoming slide, but where you can rapidly capture a whole lot of information about the site. You can capture photos and all this sort of things and tie it all in really quickly. I always recommend taking a photo of your sample bag with your site. It's a great way to solve problems sometimes if you're missing digits in your location data and other things like that tend to crop up from time to time. And looking to other supporting, getting other supporting data that can identify sample changes and where there's been problems. So I'm a big believer in getting additional information on your soil sample. So not just being focused on geochemistry, but using things like spectral mineralogy, like handheld devices, even portable XRF and other things within your analytical workflow to get additional information that can help you understand the soil properties. So spectral mineralogy is great. It gives you a quantifiable soil color, for example, that you can then refer back to and use in your interpretation. And so, yeah, I touched on the tablets that we use and QR code labels. It's all in the Explore article, which is again free download from the Association of Applied Geochemistry website. You can get those online. But what we were able to do here with the rapid tablets, we were concerned about speed and minimal sample disturbance. We're actually able to collect 5 samples in about 6 minutes. And within collecting those 5 samples, there was soils, a little gravel, 2 different plant species, and we were collecting a crust material on this arid environment. We're capturing information about the parent material, we're capturing photos of each site, and all of this because we had a well-devised strategy going into this field survey. And then there's the way you lay out your regional soil survey. So spatial configuration is one of the early things that you should look into. A lot of people like grids. Squares are really easy to work with. Offset grids are another one that's very common. This is that triangulation type approach. It does have big advantages for extrapolation of data, so the kriging and those sorts of map products that you may want to generate later on. And then the other side of it is around sampling for landscapes and feature sampling. And this is not something that is always done. I would say it's done in some of the regional surveys when people have looked at catchments and overbank survey sort of sediments. That's probably where it's most featured, in stream sediment surveys, things like that. It's not traditionally done with soils, with classic soils. And I'll show a little bit of an example around why I think we should sort of possibly look at getting away from that, especially when you're looking at getting a regional background soil survey conducted, because you want to capture the information of all the different soil types out there. So when you do focus on exploration, you know what truly is anomalous. And so, you know, I've mentioned how grids are commonly, preferred, but I would implore people to think about early on, should they be? Should we be doing grids every time? Is there better options for us? And then understanding your spacing as well is really important. So for exploration, if you're looking at small targets or small signatures, if perhaps orogenic gold may not have a big dispersion signature for gold in the cover in particular, so tighter spacing is going to be more important. Things like larger polymetallics, copper porphyries, for example, spacing can be stepped out. And then, as I mentioned, truly regional background surveys, the spacing can be actually quite broad in many cases. So a lot of Western Australia has been done on 4-kilometre sort of spacings quite commonly. And again, it's about understanding your objective for doing your regional soil survey and what you're hoping to get out of it. And that will tailor, one, the number of samples you would collect and the spacing and a number of other things. And it can be dictated by landscape understanding. So you can minimize your sample numbers, which I'll touch on again, if you understand your landscapes, particularly if you're focusing on a background approach, trying to understand a background approach. And so, that consideration of early orientation studies, again, it comes up again where if you're doing the background understanding and research before you get to the field, and as you're going through this process of devising your survey, you're going to be in better shape to get better results. And here's an example quite recently that we did where it was thinking outside the grid. And the objectives of this soil survey, it was for the Geological Survey of South Australia, was to get a representative background geochemistry of a large area. It's a couple of 100 kilometers. They didn't have a lot of access to the lands, so culturally sensitive in many cases. And this was a really interesting area because we devised the survey based on road access. We also looked at the spatial data that we had at our disposal to try and get representative soil types from that age, or representative data types that we wanted to capture. So in this case, the image on the right at the top is a distribution of pH, soil pH modeled. So, again, a little bit of human bias in that. But what we wanted to do was capture the information within that distribution of the soil pH and make sure that we had representative samples from each of those, everything from pH, 5.5 by the looks of that, up to 7, with a good representation. And so we're able to dictate where we sampled that and a number of other parameters based on a Latin hypercube design. That's not probably the important part, but it is that there's techniques out there that you can design your survey to get around limitations. And in this case, we had limitations of being close to roads, so there's only a few tracks through the area. And then you can see on the left, there's big limitations because there's a big conservation region that we weren't able to sample. And also in the red, there's government defense restricted zones, so that we weren't able to sample in there either. So we actually ran this process a couple of times. We had the green sample points, green stars with the original survey. Once we knew there were restrictions, ran the same sort of approach again, and you see the pink stars are now the most representative sample points for a number of different soil types across that area. And you can see that that's definitely not close to looking like a grid, but it is a very efficient way of getting samples in an area as a good quality background data set. Possibly a little undersampled for looking at patterns within that data. So I mentioned early on, one of the first slides about having 1,000 samples. There was only about 200 in that survey, so probably a little underrepresentative, but we had some control over the landscape elements. The other big strategy is what elements are you going to analyze for? And that is really a trick question, because the answer should always be, I should get as much elemental data as I possibly can. Now, you can't always get all elements depending on your approach and the extraction, but you should get most. Don't go in cutting corners and saying, well, I'm a gold explorer, I'm only going to get gold plus a couple of pathfinder elements. You're really underdoing your exploration approach by doing that. And there's a really great example that I was noted recently, where a nickel explorer walked off a tenement package because they'd just focused on nickel, and then the next company came straight in, looked at the same data, same sites and soils, and found a sizable cobalt resource and a rare earth deposit, just because people hadn't really bothered to look at some of the other data in there. So it's really important to consider all your other data elements. And then there's the key question that I'll probably come back to a lot, is what is the real purpose of your survey for exploration? Is it a subtle signature through cover? Because that is a very different approach to looking at maybe conventional terrain, residual settings, or if you're really interested in those resistate minerals, pathfinder, the indicator minerals, for example. Searching, if you're trying to understand lithogeochemistry approaches, and I know I think Scott Halley will give a presentation in this series as well, where he'll probably go through quite a few of those lithogeochemistry approaches. And designing a survey around, if you want that approach to work, is really important. So for his type of approach, you need, I would say, residual type soils. You want a really strong digestion to get that lithogeochemistry. But if you're looking for a subtle signature through perhaps shallow sand dune cover, well, that's not really going to help you. And in this case, that's where you should be looking at partial extractions and some of the other sample prep steps that you can do. And some of those are sort of black box techniques in many cases, but you should be open to at least looking at them, but try and get as much information as you can before applying them. And most techniques should be open about how they work. You need to understand the preparation steps and whether they're appropriate. So things like splitting, sieving, crushing and milling, I sort of touched on already. That will dictate differences in your results. Chemical pre-treatment is probably not really one that we worry about, but if you were wanting to remove an organic phase or a carbonate phase, for example, that is a consideration. And then there's the geochemist dogma about particle size and whether you should, sieve to 2 millimeters in the field. You use a 60 or 80 mesh for your chemistry. If you're doing partial extractions, you might use a smaller particle size. That's just become almost a standard, and I would say we don't often question that. There's places where coarser fractions would be better. There's places where there's no point sieving in the field. It doesn't add value to your results, depending on what technique you apply. And that dictates how much you collect too. So, if you're doing indicator minerals and things like that, you might need 5 to 10 kilos of sample or nuggety gold situation. But if you're doing one of the partial extractions on fine materials, you might need 100 grams. And you need to understand this before you get into the actual sample, into the field. The instrument finish is also important. So that ties into understanding what your approach is. And generally, ICP-MS would be the standard for most of this, but it may not always be. And I won't talk about duplicates and CRMs, reference materials, because I know Linda's also talking on that aspect and quite a bit of the analysis side. So I'll go over that quite quickly. But they are essential, and they do get you around a lot of the problems with understanding your data. So it's always something that you need to include. And I like this slide from Nick Oliver in his short course, and I've mixed it up a little bit, but he talks about pairing the right approach. In this case, he's talking about the instrumentation and some of the extractions, I think. But, it can be done for sample size as well, and picking the right sample media for your approach. If you pick a coarse media where the fine material is going to work better, you're going to end up with a poor detection limit, for example. You're going to end up with the Mr. Bean type results. Whereas what we're really looking for is the George Clooney Corvette style results, where you want, to really be good looking chemistry. And this is packaging the nicest instrumentation, the best quality detection, with a really solid approach in, how you prep your soils or what might work in the extraction. And if you mix those up, even if you get the best soil samples but mix up the analytical step, you're in for a world of pain. And that's what I like about this image, sort of highlights that. And the bottom case, where you've got George with potentially the mini, is where you've got the best instrumentation, but maybe you haven't considered the best sample media approach in this case. And I would argue that that's what we've done a lot in traditional regional geochemistry over the years. And I think you can do a lot better by getting more of the data. I've already talked about orientation studies in the literature, understanding the setting, and being really consistent. I think those messages come up again and again. Get quality analyses. So if you're unsure, talk to labs, review the literature, and contact the geochemical community. There's people presenting at this session, but other places will happily spend 5 to 10, 20 minutes of their time talking to you about geochemistry and getting you some answers. And I mentioned duplicates and CRMs already. There is a bit of an issue with people cutting costs. And again, this is modified from Nick's presentation. And I would just say, if you're thinking about saving money on the analytical side, it's not a good option. It's a real false economy where you might save a bit of money by cutting out some elements, but what you end up doing is making decisions on poorer quality data. And what I would argue is that the most important thing is actually, if you really need to save money, cut some samples out or space your samples 10% further apart if you need to save that amount of money. That's much better than cutting out your analytical options. And you can still often see the same patterns as you can see there in that little example on the left, even with 50% less samples. And getting more data. So the best offering from the lab currently is George Clooney in the Corvette, I would say. But I think we can even do better than that going forward. And one of the approaches that I'm quite keen on is the ultrafine technique that's commercialized in Australia at the moment. And that's taking out that fine soil chemistry, but it's also adding in things like particle size distribution, pH, and and spectral mineralogy. So it's a whole lot of other good quality data that we can use. Some of this, the spectral mineralogy, is one that's a little bit out there, and maybe it's a bit more like Justin Bieber and his Lamborghini, where we don't fully understand how it works. But the next generation that are much more comfortable living with different data types and merging them and working with them will really get this, just like they get the Bieber's music, I guess, and they will use it. And so we should be collecting all this extra information, even if we're not prepared to use it ourselves at the moment. And I've touched on the horses for courses. I think coarse fraction works in some places, fine fraction works in others. And it's just important to consider that before you get out there. Don't think I've used one technique somewhere and that's definitely going to be my standard for all my regional geochemistry going forward. And the same with the analytical options. Be open to exploring the different analytical options and be considerate of what you need. So again, stronger extractions for more resistate type environments or residual terrains and lithogeochemistry, perhaps weaker extractions for other subtle geochemistry through cover. And I like the example Dave Cohen and Rob Bowl put out here in more recent publication, where they took a little tweak on that and brought in the weathering aspect. So as you get more weathered terrains, you tend towards the right hand side of that diagram. And I just want to come back to why partial extractions do have value. They sometimes have been overhyped, but we've done experimental work where within burying ore in sand dunes, we can actually measure appreciable gold and base metals in that cover at the surface over about 7 months. It can mobilize up through that profile, and so it happens quite quickly. And these things are small, they're ionic, they're charged, they're likely to be bound on soil surfaces loosely. So this is the idea where by using a partial extraction or some other technique where you focus on those fine materials. So again, you can either do a partial extraction or you could maybe separate out those fine materials and analyze it. That's where you can start to get that signature of the subtle geochemistry through cover. So this is that transported cover approach, which I think has value if this is the approach you want. And you can see the results are quite good by optimizing that sort of approach. So, here's a regional soil survey done in 2000, and I would argue this is the more standard techniques with George and his mini there. Not a lot of information in the background there. However, using those exact same soil samples and changing your approach to where you're looking at an optimized sample media, a better preparation, perhaps, you're seeing that. This is the ultrafine output here. You can see that the only known gold deposit shows up, Mount Eureka there. You can see trends up through that data. So you're getting a whole lot more information there, just because took a step back to understand the setting where there is transported cover as you trend north in this environment, and you weren't getting a good signature by just diluting or assaying all that quartz, really, because there's not a lot of trace metals in that bulk transported quartz. So having that understanding before you get in there is really important. A couple of just dot points on results and interpretation. I'm not going to spend a lot of time on this, but some of the other guys will present that, I believe. Don't plot big concentrations over small ones. If you have to plot them, put the small ones on the top. It's really, I guess, not representative of your surveys. Look at your data variance and really use it. This is something that doesn't get used a lot. People often, I have interactions with industry where they're concerned about anomalous results. In some cases, it might be a 10 ppb or an 8 ppb result, and they're saying, oh, we're not really reproducing that anomaly very well. But often the background might only be 4 ppb, and there's this, you can understand the variance in that data, and actually the variance might be a couple of ppb. So, that 8 to 10 result, that's going to happen in 1 in every, 100 samples comfortably, just by the distribution of the data. That's not an anomalous result. And so understanding that is really important to interpreting. I would also argue we shouldn't extrapolate data that isn't fit for purpose. So often the error between duplicates, if it's greater than the error between sites, you shouldn't be trying to link up sites. So in this case, bubble plots are a better option than kriging and things like that, but we don't often look at that. And then bias and sample density, and this happens a lot in orientation work, more particularly, where people tend to oversample in the mineralized zone compared to background. So it's more likely you're going to get an elevated sample in that zone because you've just oversampled it. So just be aware of that. I think is probably the most important thing going forward. And now, just as I'll head towards the end of the presentation, I want to talk a little bit more about what's missing from regional geochemistry. One of the things that's happened is I think industry's lost quite a bit of confidence in the exploration approach. And I put the picture of the fonds here in because there's a term in the idiom jumping the shark, and it was where the show was starting to dive in the ratings, and so the producers decided we'll do something over the top, ridiculous, and the fonds goes out and jumps a great white shark, and the show continued to tank, and that's where the term comes from. But in exploration geochemistry, I think we've sort of jumped the shark in the early 2000s, where people made claims about some of these techniques, particularly the partial extractions, working through 50, 100, 200 meters of cover. And I just don't really think that works very often. I think we should be realistic in our expectations of our regional soil geochemistry, particularly for exploration, and put those results in context. I think we'll do better as we integrate them with other data, but we really need to not oversell the potential to explore through hundreds of meters of cover, importantly. And just where we can go a little better with what we're doing, and I think it's about putting your information in landscape context. So this is an example of a regional soil survey. And what I wanted to point out here is that we've used machine learning to integrate some of the spatial data and map different, I would call these proxy soil types. So in this case, the red is outcropping or residual terrain. So is the blue. You can see those in the box plots to the right. I've labeled them residual erosional. So that is what the sort of settings are. What's important here is that sort of purpley color and that light green. Now, those are, in this environment, sheet wash, they're transported soils, a bit of sand dune type cover. These are areas that are difficult to explore in. Now, if you evaluate that whole data set as one, which is what the white box plot does on the left-hand side of this diagram, you will pick out the anomalies with the greatest concentrations. Like this is for gold, so you're going to pick out the gold numbers, which is all the ones above the red bar. And what you see really clearly is that this technique here, we'll pick out all the high gold in the residual and erosional type settings. That's the easy stuff to find. What we miss is the stuff that's subtle in the background. And so you can see those purple, the anomalies within the purple and that light greeny color are the missed anomalous samples, because if you looked at the whole data set, you wouldn't break those out as being unusual or different. However, when you plot them like this, and you can see the arrows pointing to where they sit in the landscape, you see there's clusters of these, anomalous points. Now, those are great targets in cover, and that's a sort of thinking that I'm trying to get people to move towards in general, is using the spatial data and the information you have in your soil survey to interpret it differently, not just look at the whole concentrations. Here's another example along the same lines, and it just sort of shows how we integrate some of that spatial data. So satellite imagery, elevation, depth of cover is really important, and there are ways to potentially map that. And when you integrate that with machine learning, you can see in the bottom central map there, the ML landscapes, you can see you've got a really detailed, essentially a proxy regolith map for your whole environment. Even if in this case, I haven't been to that site. I know roughly where it is and what's involved, and other people collect those soils. But from this information, I have an idea on, where there's a fluvial channel through there and where the slopes are. The geology map on the bottom left doesn't really give me that information. So, I'm going to be hard pressed if I'm just plotting my, copper geochemistry in this case over that geology map. I might make a few, inferences about where I pick up higher copper values over maybe potentially a bit of transported cover, but I probably might miss those. And so the image on the right again shows that same sort of outlier where outliers by landscape class, where we've used that extra information to inform the way we interpret our geochemical surveys. And so, you know, the standard targets you see them regardless almost of technique and consideration. It's the more subtle targets in cover that are really going to be the challenge going forward and how we get these. And so, you know, we've identified some new targets in this setting. And then there's the other type of analytical data that we don't routinely collect. So new pathfinders will come out. I'm a big believer in, you know, the spectral analytical space and integrating that into our geochemistry. And I think we will start to see alteration mineral phases in soils, even though they're weathered and probably not as clear cut as some of the, you know, the lithogeochem type approaches with spectral data. But we don't know because we haven't really collected this, and already we're starting to see influences of soil particle sizing where we can use that to interpret some of our anomalies. So the bottom left side there, you can see there's a couple of really silty samples in the purple colors and where they spatially plot. Well, if all of a sudden they're your anomalies, you instantly know that the soil morphology has influenced your regional soil chemistry greatly. So again, it comes right back to the start where understanding that soil morphology is really important. Now, you can understand it from the context of mapping it in the field, but you can also understand it from the data that you collect afterwards, and that's what I'm trying to demonstrate here. There's other things that you might be able to pull out. So in the right-hand side here, we've got things that standard targets I've highlighted there are samples that sit up on residual settings. So they tend to be redder soils, a bit brighter in this setting. But the glade ones and the grey that sit down in the depressional zones, they're the ones that get overlooked because often they have more subtle chemistry. When you pull them out, and in this case, I've plotted them by some of the pathfinder elements and made them, you're finding new targets potentially or something of interest that wouldn't have piqued your curiosity if you just had your standard geochemistry. So that's the sort of information we're trying to get out and make it more accessible to industry. And I think it's an important consideration for all our future geochemical surveys, is not just to look at a couple of elements. And then finally, I want to close on with that aspect of going back to re-assaying and reinterpreting and adding data and value to historical samples or a new survey. Phil Baker presented this at the conference in 2015, where I think there's something like 10 million publicly available source data and source samples collected by things like government organisations and soil surveys around the world. And a lot of this was, I would say, analysed, you know, George Clooney in the mini style. You know, it's not the best quality. It was good at the time, but we can do better now. We can interpret it better too. So, you know, there's a lot of opportunity to go out and sample regional soil geochem surveys and do it better than we've done it in the past. So hopefully by listening through this presentation, you've got a little bit more of a flavour for how you can go forwards, things to consider, and how potentially there's a lot of opportunity for new discoveries in these terrains as well. And so, you know, if the Cliff's Notes, just to break it down, the key points are really around planning ahead, considering your sample media, and, you know, the analysis and what you really want to get out of it. If you want lithogeochemistry, if you want residual soils, pick a traditional technique. If you're really looking at exploration through shallow transported cover, that's probably not the technique. Look at your other options. Orientation studies are always important. And again, digging into the background literature and also the data, like that spatial data, before you get to the field, will greatly improve the ability to interpret your geochemical survey, but it will also greatly guide the way you set up and design your survey to get the best information. Be consistent, as always, with your sampling and your analytical approach. And as I touched on, but really haven't spent time on it all because I believe it's covered in other parts of this presentation, these presentations. always include duplicates, always include some sort of reference materials. It doesn't necessarily have to be a certified reference material, but you do have to include these bits of information because, or these samples, because you will get benefit out of it as you go through your interpretation. And with that, I'd just like to thank you for listening to my presentation on regional soil geochemistry for exploration, and feel free to provide questions or email me if you've got other information or other questions that you'd like to bring up in the future. Thank you.